So yeah,
if you want me to turn on the light, let me know. Okay, I'm totally fine. I think we can start now. So, good afternoon, everybody. Happy New Year. I wish you a very good semester. Okay, so my name is Mohammed Mahmoud. Okay, I'm the instructor of 3130. So this is some information about me. So this is my office in Brown Hall 332, and this is my lab 324. This is my email, my homepage. This course is gonna have one TA. This is Chujuki. This is the name of the TA. His email as well. Okay. So as you know, we're gonna have lectures on Mondays and Wednesdays from 4 until 5:15 in this room. Also, every Thursday, we're gonna have a lab, but this will be in a different building. It's gonna be at Johnson 308. This should be from 4:30 to 5:15. Okay. One more thing I want to say. This week, we're not gonna have a lab this week because I'm not gonna have enough time to teach enough material to start the labs. However, this Thursday, I'm gonna teach. So there is a lecture on Thursday, okay? So this lecture is not gonna be in this room because this room is not booked for us on Thursdays. So on Thursday, we're gonna, this Thursday, this week, we're gonna have a lecture from 4:30 to 7:15 in Johnson 308, okay? But all other weeks, we're gonna have labs, okay? I'm not sure the Zoom students, can you hear me well? Hello, Zoom students?
I can hear you.
Yeah, great. That's great. Okay. So all the course materials are gonna be posted on this link. I sent you this. I sent you an email. I think yesterday. In this email, I sent you this link for this course. Okay. Also, I sent you a passcode to open the PDF files. Okay. As I told you in the email, it's very important to attend all lectures. Okay. This should help you to understand the course. However, because we live in a very difficult time, we have Omicron, we have Delta. We have too many things, okay, for now 2 years, okay? So it may happen that some of you are gonna be quarantined. So in this case, all lectures, I'm gonna also live stream them, and this is the link is here. Also, I sent you this link in the email. Also, I record all lectures just in case you miss something in the lecture and you want to go back and or if you want to listen to the lecture again. So all lectures are gonna be recorded, and then I'm gonna post them on YouTube here in this link. I have office hours Mondays and Wednesdays from 1:30 to 2:30. Okay. I can tell you simply, my philosophy is I want you to love this course. I want you to understand it. I love it. It's a very good course, okay? So I will do my best to help you, but for sure, I cannot help you if you don't request the help. So I'm telling you, we are here. When I say we, I mean me, myself, and the TA, and also I'm in the process to recruit a greater as well. So we should be 3 people. When I say we, I mean all of us are here to help you, okay? So at any time, if you need any help, don't hesitate to ask for help. This is my job, okay? I get paid to help you, okay? Or this is my job. So if you need any help, don't hesitate to ask help from me or the TA, okay? So in this course, these are the chapters of this course. The first chapter here is about microprocessor architecture, okay? So in this course, let me take this one off. I'm gonna give you this board. Okay, this board is called a Dragon board. This board here. Okay, this board should have. Okay, just let me take this one. Yeah, this is chip. Can you see this chip here? Yeah, this is chip. This is chip, as I'm gonna explain in the first chapter. This chip is a complete computer system. Okay, we call it microcontroller. Okay, so the purpose of this course is number one, I want you to understand the basic functionality of computers, how computer works, because the architecture of this chip is similar to your smartphone. But for sure, your smartphone has more resources. It has more computational power. It has more memory. But this one also has computational power and memory. You understand what I'm saying? So this is a computer system, as I'm going to explain in this course. So number one, you should understand how computers work. Okay. For sure, I'm not going to give for sure too much details, because too much details is a different course. Okay, but you will understand very well how computers work. This is number one. Okay. Number two, I'm going to also teach how can you program this computer, little computer, okay, using C language and also assembly language, both of them, okay. Also, I'm going to teach applications, okay. So this chip can be used in many applications. So I'm going to teach how you can connect some input up. Like here we have many input output devices. Like we have here LCD. I'm gonna explain how can you program this LCD so that you can display something here. We have a keypad here. We have here a buzzer. Okay, this buzzer can make some noise. Or I'm gonna program if you wanna generate like some alarm, something happened in the system, and you wanna generate alarm. You can use this buzzer to do that. Push button, 7 segment. I'm gonna explain how can you program all of that. Okay. So the first chapter again is going to be like, I'm going to talk about architecture. I'm going to make some definition. I'm going to teach you some concepts. Okay. Chapter 2, I'm going to explain how can we program this chip using assembly language. Okay. And then after that, I'm going to explain interfacing to a microcontroller. Here, what I mean by interfacing is, how can you program input output devices here? This one. How can you program input output devices? Okay. In chapter 4, I'm going to explain something really very important, very useful. We call it interrupts. We are going to understand it. Very important, very interesting. Finally, I'm going to talk about timer function and pulse width modulation. Okay. So I think I did most of this one. So here, the main objective of this course is just to understand the basic terminology in computer architecture, to understand how computers work, also to program using assembly and C language, and also do some applications. One of the things you are going to notice in this course, I told you, you should be able to program this microcontroller using both assembly and C, right? Even in the final exam, I'm going to give you 2 questions, okay? One question, I'm going to ask you to program it in C. The other one, I'm going to ask you to program in assembly. So that means I'm expecting that you should have the same skill. C or assembly should be the same level, okay? That's what I mean, okay? So you will notice that assembly programs are very detailed. There are a lot of details, okay? C language is high level, okay? You will better understand what I mean by high level and low level, right? High level means using maybe one instruction, as you will see in this course, in C language. This instruction, okay, is gonna be, in order to do the same thing using one instruction in C, you have to write 10 or 5, 6, 7 instruction in assembly, because assembly is very detailed. You got what I'm saying? You should understand that assembly should be run by the hardware, okay? Also, you will understand very well in this course that whatever programming language you are using, if you use Python, if you use Java, if you use C, use whatever you use, okay? The hardware doesn't understand all these languages, okay? Java is your language. This is not the hardware language. C is your language. It's not the hardware language. Okay, so whatever the language you are using, we have to convert it to assembly. Okay, or what we call machine code, right? So machine code, instructions that executed on by the hardware. You understand what I'm saying? So that's why it's two different worlds. Okay, C language is a world, but in reality, or what happens in reality of the hardware, it's going to be something completely different. That's why we use compiler. We use assembler to convert the high-level language to low-level. Okay, but this is the reality. The reality is whatever program you are writing is not going to be executed in this format. It's going to be executed by the machine code, by the hardware. Okay, that's all assembly. Okay, so anyway, so you will see that C language is very compact. Okay, see, you will see the C program is very short, but the assembly is long. Okay. Anyway, I don't want to debate here if C is better or assembly is better. Okay. That's why I'm going to give you some freedom in projects. So when you do the project, as I'm going to explain, I'm going to ask you whatever language you are using, it's okay. If you want to use C, it's okay. If you want to use assembly, it's okay. You got what I'm saying? But anyway, I'm going to clarify the difference between both of them, C and assembly, anyway, later in this course. But for now, assembly is detailed because everything you are writing in assembly is going to be executed by the hardware. And this is not the case in C. Okay. C language hides a lot of details. Okay. If you want to do something, just use this instruction. That's it. But in reality, this instruction has to be broken down. It has to be broken down into a set of instructions. Okay. So that's why I see assembly as the reality. Assembly is the reality because this is what's going to be executed by the hardware. Okay. Anyway, so you should learn both of them. For the textbook, you have this book. Okay. However, I don't think you need this textbook. You have the slides. The slides are very detailed. Okay. I think it's enough. If you want to buy it, that's okay. But I don't think you will need it. The slides are very detailed. So you can understand this course from the slides. Okay. This is the course. This is how I'm going to do the evaluation of this course. Number one, we have homework. This homework is going to be 10% of the final grade. Okay. We have project. Okay. This project should be 15% of the final grade. This project, as I'm going to explain later in this course, this project can be done individually or groups of two. So two students can work together on in one project. And this is a typical case. So the typical case, usually two students in one project. In some rare cases, I allow it more than two students to work on one project, but you need to justify. For example, if the project is big enough and you need four students, 3 students, I'm totally fine. You got what I'm saying? But typically, it's 2 students can work on each project. I think project is very important. Doing good project is very important to understand this course. That is why I want to encourage you to do very good project. The way I can do it is just by giving you 5% bonus marks. Okay, this 5% is 5% on the total. It's not 5% out of the 15 or something. It's on the total. You got what I'm saying? So I'm going to show some videos shortly. I'm going to show just in a few minutes. I'm going to show some videos for a very good project students did before. Okay, so I hope again, I'm not asking everybody to do or to do like very high level projects. Again, I'm very realistic. But anyway, if you wanna do more work, I'm totally fine. So, and when the time comes, I'm gonna give you more details. I'm gonna tell you, okay, if you wanna do the minimum, you have to do this. Okay, if you wanna do more, okay, and you wanna learn more, I'm totally fine, and I can give you up to 5% of the bonus marks. But anyway, so we're gonna talk about this one later. For labs, we're gonna have around 10 or 11 labs. Okay, on Thursdays. Labs should be 20% of the final grade. Again, typically, in labs, you can work in groups of 2. So 2 students can work together in one group, in one lab, okay? typically, but again, some students, for some reasons, they want to work individually. Okay, I'm totally fine with that as well, but no more than 2 in labs. Okay. We're gonna have quizzes almost every week. We're gonna have one quiz. These quizzes should be 15% of the final grade. All quizzes are gonna be during the lab session. Okay. At the beginning of lab sessions, we're gonna have a quiz. This 15%, we're gonna have two tests, 15%. Okay. The final exam should be 25%. So if you add everything together, it should be 100%. Okay. If you add the 5, 105. If you add this 4. Any question? Is that clear? Okay. So I wanna tell you something here. Good news. The good news is all exams are open book, open slide assignments. Is that okay? So you don't need to worry about it. This is important in this course because we have too many instructions. So you don't need to worry about memorizing anything. Okay. So you're gonna have all it's open book, so you can any printed material should be okay, but electronic devices are not allowed. Okay. So even if you have assignments, labs, I'm totally fine. Okay, so that's good. You don't need to worry about memorizing anything. Okay, you need to worry about if you understand the topic, you should be able to solve problems. Is that okay? This I'm gonna do this in quizzes, in tests, in final exam, in everything. Okay, it's open. It's gonna be open book. I want to tell you something important for labs, as I told you, labs and projects are usually done in groups. Okay, as I told you, at least a group of 2. Okay, you can do the same lab, it's the same project. Even every group, I'm gonna ask every group to submit only one report. Okay, for labs. So it's totally fine to work in groups, project and labs. However, for sure, for quizzes or tests or the final exam or homework, this should be done individually. Is that you understand what I'm saying? So for homework, you have to do it only by yourself. It's not in groups. Okay. Any questions? Great. So here, I give you some advice here. What should you do to understand this course? I think it's very important to attend lectures and labs. Okay. Believe me, if you can understand the lectures, if you can understand do the labs by yourself, if you do the assignment by yourself, you are not going to have any difficulty in the final exam. It's going to be too easy. Okay, I can guarantee that. You understand what I'm saying, guys? So you have to do everything by yourself. Please don't copy from others, because if you do that, you're not going to be able. Maybe for sure, if we know that you copied from someone, we're going to take action. But even if we don't know, you're going to struggle in the final exam. You got what I'm saying? So you should show the slides are very detailed. Just read the slides. You are going to have lectures are live streamed. You are going to have recorded lecture. If you do the labs by yourself, understand it as a course, everything will be very easy in this course. Okay. So, and again, I'm going to repeat it again, guys. We are here to help you. Okay. I will be very happy if you understand this course and you love this course. Okay. So if you have any question, don't be shy. There is no reason to be shy. We are here to help you. If you need help, just let me know. Okay. During labs or emails or whatever. Okay. So class participation is important. If you have any questions, just raise your hand, ask me. That's totally fine. You have to do homework by yourself. Okay. Turn in all labs, homework, and so on. I'm gonna tell you something very important, guys. Listen to me. Not all labs have the same weight. You understand what I'm saying? Some labs is gonna be, for example, graded out of 30, 40, but some other labs may be out of 60, so they not have the same weight. So you have to consider this. You understand what I'm saying? So not all the labs, or not even all the assignment, or all the quizzes, it depends on the level of difficulty. So not all of them have the same weight. Okay, so some labs have more weights than others and so on. So you should, my advice to you, you should do your best to collect as much as you can, okay, so that you can get a good grade in this course. Okay. Anyway, I just give you some advice here. Okay. One more thing, as I told you guys, all the chapters are posted in PDF format. Okay, and they are protected using a password. Okay, I already emailed you this password in the email, but just I want to tell you, so it may be very boring. Every time you open a file, you have to type a password. No, you can cancel it. Okay, after you download the file, you can cancel the password. The way you can cancel it, as I'm showing it here, you can just open the Adobe Acrobat Pro and then click File and then click Properties here, and then you can go here Security. You can select No Security. You understand what I'm saying? So after you download the file, you can cancel the password, so that next time when you open it, you don't need to type the password. Okay. However, I want to tell you, some student came to me and in the last semesters, and they told me, we don't have this option you are showing here. Yes, because you are using a different Acrobat reader format version, or a different version. Okay. So you have to make sure. So what I'm saying, for some reason, some versions don't allow you to do that. Don't have these options. So this is from the Acrobat reader. Okay, so you need to find this version somehow. Okay. Anyway, so again, before I finish this introduction, I just want to go back again, guys. Look here. This is I want to just repeat some links, very important links you need. I already sent it in the email. By the way, if you didn't receive an email from me, okay, that means you are not in the mailing list. Okay, so please let me know to add you. I got all the emails from maybe from the Eagle Online, but maybe some of you already registered too late. Okay, so anyway, if you don't receive the first email from me, that means you are not in the mailing list, and let me know to add you. Okay, so again, this is the website for the course is here, and you can reach it to this one in a different way. So you can go to Google, for example. You can here in Google, you can type, for example, here, GN Tech, and then my last name, Mahmoud. And then, yeah, this is then you can go to teaching. Yeah, if you go to teaching, you will find it here, spring 2022. Yeah, so this is the web page of this course. All the announcements are going to be here. I already posted all the chapters are here. Okay, you can just download them from here. All assignments are going to be here. Any information about the projects are going to be here. Labs are going to be here. Also, you have other resources here. I'm going to talk about them later. Okay, guys, any questions? Okay, one more thing we have here. As I told you, this is for Zoom, in case if you have some emergency, or if you are in quarantine and you wanna join me using Zoom. Also, this is the YouTube here. You need this one. All the videos, I'm gonna post all the lectures here. Okay. One more thing I want to show you guys, as I told you here, this is videos of good projects some students did before. So again, I'm gonna open them. I'm gonna show you quickly some of the very interesting things the students did before. So let me see. Yeah, I like this one. Let me see. This is the one I'm looking for here. You can see the board, Dragon board is here. So there is a sensor here at the head here. You can see this is a sensor here. This sensor can measure the distance, and based on the distance, it can make a decision to move right, move left, whatever. We have here also some of interesting other things here. Yeah. Let me see some of the interesting things here. Let me see this one. Yeah, this is candy sorter. It's very interesting also.
Hey guys, I just wanted to showcase the current state of the color sorter.
So what happens here, guys, is there is a color sensor here. This is a sensor, you can see it. This is a sensor for color. Based on the color, he's gonna put like a candy here. Based on the color, this arm is gonna take this candy, put it here or here. Okay, based on the color. So, sorting. Okay, so let's see.
Candy box, put it up against the sensor. Sensor gripper's gonna come down, it's gonna grab the box. Gonna move the box over to the correct bin. Take my purple. Take my purple box, put it up against the sensor. It's gonna recognize it. It's gonna grab it. It's gonna put it in the correct bin. I'll do it one more time just to show you guys how to program that. There. Grab the box. Boom.
Okay. Let me see if we have here other things. What is that? Let me go back to here. Anyway, maybe I don't want to spend too much time on this, but yeah, some of these really very interesting projects. Yeah, I think this is also one of the interesting ones.
Tennessee homeowners, if you have a power meter like this on the side of your house, you can qualify to erase your energy.
Okay. So you can see here, guys, this is the smartphone, and this is using Bluetooth. It can communicate with the Dragon board using Bluetooth, so that, as you see here, you can move this arm right. Okay. So the communication here using Bluetooth. Yeah, this is also very interesting one.
This is Rodrigo Duarte, and this is our invisible piano using the HCS 12
This is a very interesting piano.
Dragon board.
Okay, the way it works, as I'm going to explain this course, guys, this is a sensor for distance. Sensor for distance, these two here, right? So what happens if you put the box here, you are going to measure the distance. And based on the distance, we are going to play a certain tune. That's why it becomes a piano. Once I move the box this way, okay, if I put the box here, it's going to be one tune. If I put here, a different tune. If I put here, a different tune. So this becomes like a piano, very interesting. So the tune should be generated from this puzzle, okay? This puzzle, this is the tune. And we have here sensor to measure the distance, how far this box from here. Anyway, I'm going to show it quickly.
So what we have here is an ultrasonic sensor, which is going to emit a signal, and when it hits the object, it will come back and it will read the time that it took to come back and display the distance. So see, now it's showing the distance that I moved the box. And if I hit this button, it will begin to play the sound that corresponds with the distance. So now it's playing F3. As you move it out, it plays different notes. See, that's B4. You can go all the way out. So here, come all the way back. You can pause the sound at any time with this button or turn the system off. Put PH0.
Anyway, you have other projects here. I don't want to spend more time on this, but we have really very good projects here. You can look at, you can see them. Yeah, I think this one may be also interesting.
So right here, we have the phone launcher.
If you press this button right here, it will make the motors go full speed. If you press this, it will make it go medium speed. And right here, it will turn everything off. We have a servo motor connected to for the bulbs, and then right here we have one of the DC motors connected.
Anyway, guys, okay. So anyway, again, this is more than my expectation. I don't want to scare you. So what I want to say, what I'm going to do in this course, guys, I'm going to tell you, I have a certain expectation, okay, which is realistic expectation. If you do it, I'm totally fine. If you want to learn more, if you want to do more, also, I should encourage you to do that. That's why I'm going to give you bonus marks. Is that okay? Anyway, I think projects are important to understand and learn this course. Anyway, so I think this, any question here before I start the chapter 1? Any question, guys? Okay. So sorry, I'm going to repeat it again. So Thursday, there is no lab. Okay. However, I'm going to teach the selection on Thursday. Okay. It's not here in Johnson building. Okay. Every Thursday has to be in Johnson. Every Monday and Wednesday should be here. Okay. So now I'm going to start the chapter 1. So in chapter 1, I'm going to, in the beginning here, I'm going to make a very quick revision on the number systems. Okay. Yeah, this student, I'm going to mute the students. Yes. Okay. Anyway. Okay. Okay, guys. So let's start. I'm going to make a very quick revision on the number system, guys. So there are different number systems. There are different systems for numbers. Okay. You are already familiar with some of them. So here we have binary numbers. We have hexadecimal numbers. We have decimal numbers. Okay. So we have other systems, but in this course, I'm going to focus only on these three system because that's what we need. Okay. So number one, you know, in binary number, we have only 2 digits, either 0 or 1. So I can write any number, 1 billion, 2 billion, any number. I can represent it using only 2 digits, 0 or 1. Okay. That's binary, right? For hexadecimal, for decimal, that's what we are using in our life, right? That's what we use. So here we have 0. Okay, sorry, I have to be close to the mic. So here we use digits 0 from 0 to 9. That's what we use in our daily life. Okay. Also, forget this PB, it's a mistake. So anyway, for hexadecimal, in case of hexadecimal numbers, we have digits from 0 to 9. Okay, and then we have A for 10, B for 11. We have C until F, which is 15. Is that okay? So now, so these are the system we're going to use in this course. So number one, why in this course we need the binary number? Why we need the binary number here? I'm going to tell you why. Because I'm going to tell you something very simple. Okay, let's agree on this. Computers, any computer system, including this chip. This chip is a computer system, as I'm going to explain in this course. Okay, so any computer system you should use, or any computer system uses only binary numbers, 0 and 1s. Everything here, as you will see in the first lab, everything is 0s and 1s. Okay, your program is just a bunch of 0s and 1s. Your data just a bunch of 0s and 1s. Okay, so any computer system can only understand 0 and 1. So this is the language. This is the language of the microcontroller here. That's why we need it. Is that okay? Why we need the decimal? Because this is the language for us, only for us, because this is the language we are using. This is a system for human, not for the microcontroller. The microcontroller doesn't understand the decimal numbers. It's just for us. It's like different language. Is that okay? You have question? Okay. So now the question is, so we need decimal because that's what humans are using. We need binary because this is the language of computers, okay? And as you will see in this course, everything is represented in binary. Data, instruction, everything binary, just a bunch of ones and zeros, okay? So now the question is, why we need hexadecimal? Who is using the hexadecimal, right? So we need binary because this is for the machine, this is for human. So why we need hexadecimal? I'm gonna tell you why we need hexadecimal, okay? In hexadecimal, guys, as you know, every digit here, when you convert hexadecimal to binary, every digit is represented by 4 bits, as you know, okay? So for example, this is hexadecimal, this is binary. So 0 should be number 0, right? 1, this is number 1, okay? 2 should be, if it is 2, should be 0, 1, 0, 0. This is 2, you know why? Very quick revision, because you know the weight of this one, 2 to the power 0. The weight of this one, 2 to the power 1, 2 to the power 2, 2 to the power 3. So that's why this one here should be 2. This is number 2, okay? And so on. If it is 8, number 8 should be 1, 0, 0, 0. This is number 8, right? And so on. So, and then A, let me come here. A is 10. 10. Okay, so 10 means 1, 0. Sorry, 1, 0, 1, 0. This is 10 because this is 1, 2, 4, 8, right? So this is 10. B is 11, okay, which is 1, 1. Which is 1, 1, 0, 0, okay? All the way until F. F is 15, and 15 means 1, 1, 1, 1. Okay, guys? So let me say it again, very simple. So every digit in hexadecimal is represented by 4 digits in binary, starting from 0, 0, 4 zeros, which is number 0, all the way until 1, 1, 1, which is F. Because that's all the digits we have in hexadecimal, from 0 to F. Is that okay, guys? So in total here, we have 16. And also in total here, we have 16 different combinations. Yes. Oh, sorry. Yes.
Shouldn't be 1, 0, 1, 1.
I made a mistake here. So this is 11. Yeah, you're right. Because this is 8. This one here, right? Because 11. Yeah. 8. Yeah. So 8, 2, 1, 11. Okay, that's great. So now let's agree on this. Every digit in hexadecimal is represented by 4 in binary. Okay. So now I want to answer the question. We need decimal because that's what humans are using. We need binary because this is what the machine is using. So why we need hexadecimal? Okay. Who's using hexadecimal? Okay. Very simple. The answer is no one is using hexadecimal. Okay. So if no one is using hexadecimal, why you are using it? Because it's more convenient for us. If you want to give you a binary number, it's shorter, it is more convenient to give you the number in hexadecimal instead of ones and zeros. So it is only for human. For example, let me explain what I mean exactly. So hexadecimal is shorter representation. Why it is shorter? Because every 4 digit in binary, I'm gonna make it only 1 digit in hexadecimal. That's why it's shorter. You understand what I'm saying? Number 2, it's easy to convert binary to hexadecimal or hexadecimal to binary. It's very easy. You know why? I'm gonna tell you why. For example, if you have like 3A, this is hexadecimal, 3A hexadecimal. For example, all what you have to do, this is 3. So every digit here, I'm gonna convert it to 4, right? So this is 3. 3 should be 1, 1, 0, 0. This is 3. This is 10. 10 should be 1, 0, 1, 1, 0. Is that okay? So if you want to convert between hexadecimal to binary or binary to hexadecimal, it's much easier than using decimal. Is that okay? So what I'm saying here, guys, if I want to give you a binary number, it's going to be very difficult for us if I give you 0, 0, 1, 1, 1, 0, 1, 0. It's going to be very difficult for us. Instead, if you want to give you a binary number, I'm going to give it to you in hexadecimal. You understand what I'm saying? So for example, let me give you another example to understand exactly what I want to say. Okay. In this course, for example, this is a memory. This is a memory. This is the location 1000. In every location, we store a byte. In every location, we store 1 byte. If I tell you, listen to me, that's what we're going to do in this course. If I tell you, in the location number 1000 in the memory, I store the number 3A. 3A. Okay? Actually, it's not 3A. Actually, what is stored in this location is 00111010. However, I'm going to give you 3A because it's easier for us to use hexadecimal than using binary numbers. You understand what I'm saying, guys? So you should understand no one is using hexadecimal numbers, but just in case I want to give you binary numbers, it's easier for us to give it in hexadecimal than giving it to you in binary. Okay, guys. So let's agree on this. Everything stored in memory should be stored in binary. So when I tell you this location is stored to 3A, right? Actually, it's not 3A. It's this binary. You understand what I'm saying? But just easier for us to use hexadecimal because it's just a shorter representation. It's just more convenient to humans to use hexadecimal than binary. Any questions? Okay. Conclusion. In this course, we need these 3 number systems, binary, because this is what the machine is going to use. Hexadecimal, that's what humans are going to use. We're going to use hexadecimal just because it's a shorter representation to the binary, okay? Just more convenient for us. Now I'm going to explain, I already explained it, but I'm going to go through it quickly. If you have a hexadecimal number, how can you convert to binary? Or if you have a binary, how can you convert it to hexadecimal? Okay, guys, very easy. Look here. Here, in case of hexadecimal, as I explained earlier, if you every digit in hexadecimal has 4 bits in binary. Okay, so for example, 0 is 0, 0, 0, 0. Okay, and so on until F. F is 1, 1, 1, 1. Is that okay? So all what you have to do, guys, is if you have a hexadecimal number and you want to convert it to binary, all what you have to do is, for example, I have something like this. F0. This is hexadecimal. I want to convert to binary. Very simple. Very easy. So that's why I'm saying the conversion between binary to hexadecimal or hexadecimal to binary is very easy. All what you have to do is remove this digit, replace this digit with the 4 bits. Okay? F means 1, 1, 1. 0 means 0, 0, 0. Okay, this is what you have to do. Okay? That's it. It's done. So every digit in hexadecimal, you have to replace it by its corresponding 4 bits. You understand what I'm saying? For example, if you have here A is 10. 10 means 1, 0, 1, 0. 9 should be 1, 0, 0, 1, and so on. Okay, any questions? So it's very easy. So if you have hexadecimal, just replace every digit by the corresponding 4 bits. That's very easy. Okay, this is number 1. Number 2, how can you convert the binary to hexadecimal? Binary to hexadecimal. You are going to do the opposite. All what you have to do, number 1, I have the binary number. I have to create groups of 4, right? 4 bits. And then, based on the conversion here, so for example, if I have this one in binary, I'm going to use this one. If I have this one, I'm going to use this one, and so on. For example, let's see, for example, this number here. 1, 1, 1, 1, 1, 1, 0, 0. Okay, so you have to start right to left. You have to create group of 4. So this 4, 1 group. This 4, 1 group. And 1, 1, 1, I'm going to replace it by F. 0, 0, 1, 1, I'm going to replace it by 3. Yeah, so very easy. So if you have any binary number, guys, any binary number, you have to start right to left. You have to create group of 4. What if the last one is not 4? Very simple. Just put 0. If you put 0 in the left, 0 is not going to make a difference. For example, here, this 4 should be together, and this 3. Okay, I'm going to add 0 here. That's not going to make a difference. 0 here. Okay, and then what this number is? This number is 8, 2, 1. So it's 11. 11 is B. right? It's P. And this one, 1110, is number 7. So this one should be 7B. Any questions? Very easy, right? So all what you have to do, you should have this one here. If you have hexadecimal, just remove every digit, replace every digit by the 4 bits. Or if you have binary, remove every 4, replace every 4 by this digit here. Is that okay? Any questions? So now you should understand how can you convert the binary to hexadecimal, hexadecimal to binary. Also, you should understand no one is using hexadecimal in reality. You understand what I'm saying? However, it's just easy for us because binary is terrible. Binary is too difficult. Can you remember this number 1011010? You cannot remember it, right? But if I tell you 3A, 2F, yeah, it's easy for us to remember. You understand what I'm saying? So very important. When I tell you in this memory location, it is storing 3F, that means the binary version of 3F. But just it's more convenient for me to use 3F than using 11010. Okay. Any questions? Okay. Next. So if I tell you I have 10 apples, 10. So how many apples I have? Someone can tell me you have 2 apples because 10 is a binary number. Someone else can tell me you have 16 apples because 10, if it is in hexadecimal, should be 16. This is 16 in hexadecimal. Someone else can say, no, you have 10 because this is decimal. All of them are true because I didn't clarify what the system is. You understand what I'm saying? So I have, this is not something I have, I can guess. This is something you have to tell me what the system is. Because 10 can mean 2, it can mean, or it means 16, or it can be, also it means 10. So you have to tell me if this one is binary or hexadecimal or decimal, okay? How we are gonna do this in this course? Very simple. We are gonna use a prefix. Okay, what kind of prefix we are gonna use? If you use a $sign, this $sign, that means this is hexadecimal. If you use percent, that means this is binary. If you put nothing here, no prefix, that means it's decimal. Is that clear, guys? Makes sense, right? So you have to tell me. This is not something I can guess. You have to tell me if this number is binary or hexadecimal. Okay, so all the time we are going to use this prefix here. Okay, again, $sign means this is hexadecimal number. Percent means this is a binary number, and this is nothing is decimal number. Okay, any questions? Okay, so now I want to explain how can you convert binary number to decimal. So what I'm going to explain now, I already explained how can you convert hexadecimal to binary or binary to hexadecimal. What I want to explain right now, how can you convert binary numbers to decimal? Okay, so there are two cases. There are two cases here. If your number is unsigned, okay, I'm gonna do it this way. However, if your number is signed, I'm gonna do this way. Okay, wait a second. So what you mean by unsigned? I mean, my number can be 0 or positive. That's the meaning of unsigned number, right? What do you mean by signed number? That means the number can be positive, it can be 0, it can be negative. Is that okay? Any number can be signed or unsigned. I can give you example. For example, I want to count the number of cars. I want to count the number of students. I want to count the number of anything, right? This should be signed or unsigned. In this case, this one can be unsigned because the number of cars can be negative, right? It's always 0 or positive, right? So this is something you have to decide in your program. So in your program, if you have different data, you have to decide this is signed or unsigned based on what this variable is going to measure, right? For example, if you want to measure something like temperature, yeah, temperature can be positive or can be negative, right? And so on. So anyway, so based on what this number is represented, it can be unsigned or it can be signed numbers. Okay. So now, if you again, number one, you should understand. Number one, numbers can be signed or unsigned, right? Based on what they are measuring, right? If I use a number for number of cars, it can be negative, right? temperature, yeah, it can be negative, right? So anyway, number two, what I'm going to explain right now. So if your number is unsigned, if I give you a binary number and I tell you this is unsigned number, how can you convert to decimal? Okay, same thing. If your number is signed, how can you convert it to decimal? Because now I'm going to explain two different cases. Let's take the first case, the easy case. So number one, if your number is unsigned, how I can convert it to binary? To decimal. All what you have to do, guys, here, you have to every digit here has a weight. You already learned this weight before. So the first one here on the right, the weight is 2 to 0, which is 2. The weight of this one 2 to 1, which is 2. 2 to 2, which is 4. 2 to 3, okay, 2 to 4, which is 16, and so on. So every one here has a weight. 2 to 0, 2 to 1, 2 to 2, 2 to 3, 2 to 4, 5, 6, 7, 8, 9, 10, and so on. Makes sense? So everyone has a weight, right? All what you have to do is, I'm going to multiply this digit by this weight, plus this digit by this weight, plus this digit by this weight, and so on. So in this case, if I have this number, 1, 1, 1, 1, 1, 1, 1, 1, so 1 times 2 to 0, 1 times 2, 0. And then 1 times 2 to 1. 1 times, if I add everything together, I'm going to get 255. Okay, guys, is that okay? That's what you learned before, right? So all what you have to do is, this is if the number is unsigned. If the number is unsigned, this is what you learned before. All what you have to do, just to multiply every digit by its weight, add everything together, you are going to get the decimal number. You understand what I'm saying? So 255, this is the number humans are using. The equivalent number, the computers are going to use 11111, as you see. Is that okay? Now, this is the first case. If I tell you this number is unsigned. Now, if I tell you this number is signed, okay, there is a different case. Let's see. If the number is unsigned, that means the number can be positive, it can be 0, it can be negative, right? How can you know if the number is positive or negative? How can you know? Very simple. Yes. That's true. From the most significant bit. So what do you mean by most significant bit? Okay. That's true. So for example, if I have a byte here or a word, byte, whatever. So the first bit at the right here, okay, see, this one has the least weight. The least weight, because this one is 2 to 0, right? So that's why this bit, we call this bit the least significant bit, or LSB, least significant bit. Is that okay? Because this one has the least weight. However, the one here, we call this one the most significant bit. Is that okay? Makes sense, because this one has the highest weight. So here, this one is the most significant, least significant. So now let's return to the question. If I give you a number, right? And I have to tell you, if I tell you this number is unsigned, that means I cannot ask you if it is positive or negative. It doesn't make sense, because unsigned is always positive, right? However, if I give you a number and I tell you this number is signed, right? So this number can be positive or it can be negative. How can you know? Very simple. All what you have to do, guys, very simple. All what you have to do, just look at this one here. If the most significant bit is 0, that means this is a positive number. If this bit here is 1, that means this is a negative number. Very simple. So if I give you a number and I tell you this is a signed number, and if you want to know this is a positive or negative number, just who's going to tell you the most significant bit? 1 means negative, 0 means positive. Okay, guys? Now, the way I'm going to use right now to convert the positive or negative is going to be different. That's why you need to know if it's positive or negative, right? So let's start. So now, if the number is positive, positive means the least significant bit is 0, right? So if I have a positive number, how can I convert it to decimal, right? So what I'm going to do here, guys, similar to what I did here. Same thing. You have 2 to 0, 2 to 1, exactly same thing, right? So for example, if I have a number like this one, guys, 1, 1, 1, 1, 0, 0, 0, okay? And I tell you this number is signed, now convert this number to decimal. Okay, number one, you have to look at the most significant bit. This is a positive number. And because this is a positive number, the way I'm going to convert it similar to the unsigned, 2 to 0, 2 to 1, 2 to 2, 2 to 3, and so on. Is that okay, guys? So, for example, this number here, 1, 1, 1, 1, 0, 0, 0. So I'm going to look at this guy. This guy is 0. That means it's a positive number. So the way I'm going to convert it, 2 to 0 plus 2 to 1 plus 2 to 3 plus 2 to 4. That's it, because all of these are zeros. If I add everything together, I'm going to get 15. So this number is 15. Okay, guys? Any questions? Okay. Now, if the number is negative, okay, if the number is negative, something like that, that means there is a 1 here. How can I convert it to decimal? Should I use 2 to 0, 2 to 1, 2 to... No, you should not use 2 to 0, 2 to 1, 2 to 3. Okay? Before I tell you how we are going to convert it, I want to explain to you something we call the 2's complement. And you will understand what is the 2's complement and why we need it. Okay, so let's start with this one first. So we have something, guys, we call it, first we have something we call 1's complement. So we have 1's complement and we have 2's complement. 1's and 2's. For example, if I give you a number like this one, guys, look here. 1, 0, 0, 0, 0, 0, 0, 0. This is a number, right? If I calculate the 1's complement of this number, the 1's complement means just flip the bits. That's what we call 1's complement, right? So the 1's complement of this number is, this one should be 0, 0 should be 1. Just flip the bits. So this one, this number here is the 1's complement of this number. Very easy. So if I give you a binary number and I tell you to calculate the 1's complement, how can you do that? Just flip the bits. That's it. So this is the 1's complement. Is that okay? Now, if I add 1, if I add 1 to the 1's complement, I'm gonna get what we call the 2's complement. Add 1. So all what you have to do, guys, here, look here. So this is the number is here. I'm gonna calculate the 1's complement. So 1, 0, 0, 1, 1, 1. So this number here is the 1's complement for this number. If I add 1, I'm gonna get this number, which is the 2's complement, right? Again, there are different ways to calculate the 2's complement. There are different ways, right? If you can calculate in a different way, I'm totally fine. But the way I explain it, I like it because you don't need to memorize anything. All what you have to understand, we have 1's complement, add 1, you are going to get the 2's complement, as you see here. Is that clear? Any questions? So you should understand, if I give you a number, if I ask you to calculate the 1's complement, all what you have to do, just flip the bits. This is the 1's complement. If you add 1, number 1, if you add number 1 here, what you are going to get, we call it 2's complement. Is that okay, guys? Okay. It looks okay. I know. Now you should know how can you calculate the 1's complement and how can you calculate the 2's complement. But, okay, so what 2's complement means? What it means? Okay, very important to understand what it means, okay? 2's complement, guys, this is the way we use to represent the negative numbers. 2's complement, we use it to represent the negative numbers. What you mean? I'm going to tell you what I mean. Look here, guys, very simple. If you have any positive number, if you have any, for example, this number here, look at this number, guys, 1, 0, 0, 0, 0. Okay, what this number is 1, right? This number is number 1 in binary, right? This number is 1. If I calculate the 2's complement of this number, I'm gonna get -1. Okay, so if I calculate the 2's complement of this one, I'm gonna get this number. How? Okay, as I explained, number 1, you should flip all the bits. This is the 1's complement, and then add 1. So this one here should be the 2's complement. So same thing for any number. So if you have number 70 in binary, if I calculate the 2's complement of 70, I'm gonna get -70. If I calculate the 2's complement of -70, I'm gonna get 70. So the 2's complement is similar to multiply by -1. Multiply by -1. That's what I'm saying. So in any number you have, if I calculate the 2's complement of this number, I'm gonna get the same number but in a different sign. Positive So I'm gonna be negative. Negative is gonna be positive. You understand what I'm saying? So here, so this is the importance of two's complement. Two's complement is used to represent negative numbers. Is that okay, guys? So now, same thing here. I'm giving you one example here, guys. This is number 7. 1, 1, 1, 0, 0. This is number 7. Now, if I calculate the two's complement of this one, I'm gonna get this one. So this one is actually -7. How you calculate the two's complement of this one? Very easy. Just flip the bits. This is the one's complement and then add 1. So I'm gonna get this one. So this one, so this number and this number should be the same, but this is positive and this is negative. Understand it? Okay. Any questions? So now, that's what I'm gonna ask in the quiz. I'm expecting you should be able to calculate the one's complement. If I give you a number and I ask you to calculate the one's complement, it should be very easy, right? Same thing. If I give you a number and I ask you to calculate the two's complement, it should be very easy, right? Not only that, you should understand what it means when you calculate the two's complement of a number. That means I'm gonna get the same number but in a different sign. Okay, so if this number is +7, if you calculate the two's complement, I'm gonna get -7. If you calculate the two's complement of -7, I'm gonna get +7. That's why the two's complement, it means it's similar, you multiply by -1. Is that okay, guys? So anyway, so now let's return to our question here. If your number is negative, how can you convert this number to decimal? Okay, again, there are different ways, but I'm going to tell you the easy way, in my opinion, but there are different ways. Okay, all what you have to do, guys, is calculate the two's complement of this number. This is a negative number. All what you have to do, just to calculate the two's complement. Okay, when you calculate the two's complement, you are going to get the same number but positive, right? And now because the number is positive, I can just use it 2 to 0, 2 to 1, 2 to 2, and so on. I don't understand what you are saying. Okay, I'm going to tell you what I mean. For example, I'm going to give you a number like this one, guys. Look here. Listen to me. 2 cases. If I tell you this number is unsigned, in case of unsigned, we have only one way. Very easy. So all what you have to do, guys, 2 to 0, 2 to 1, 2 to 2, 2 to 3, 2 to 4, 2 to 5, 2 to 6, 2 to 7. If you add everything together, I'm going to get 255. I'm done. In case of unsigned. However, if I tell you this number is signed, is that okay? Number 1, you have to look at this one. That means this one is a negative number because it's 1. It's a negative number. And because it's a negative number, I cannot just use 2 to 0, 2 to 1, 2 to 2. You cannot do that. Right? So what should I do? Very simple. Calculate the two's complement of this number. Let's do it. So now I'm going to calculate the two's complement of this number because it's negative. So the two's complement is number 1, the one's complement. One's complement, you just flip the bits. This is one's complement. And then add 1 to get the two's complement. So 1, 0, 0, 0, 0, 0. So now this number is the positive version of this number. This number is the positive because when I calculate the two's complement, I multiply this number by -1. So this number and this number should be the same, but this is negative and this is positive, right? So all what you have to do, guys, for the positive one, you can use now 2 to 0, 2 to 1, 2 to 2. So this number is 1. That means this number should be -1. Any questions? So let me tell you the conclusion, just in case you have any question, because that's what I'm going to do in the first quiz. I'm going to just, my quizzes are not difficult. If you just understand what I'm saying here, you can do it. You understand what I'm saying? So I'm going to give you a number. I'm going to tell you convert this number, calculate the two's complement. For example, can you, for example, look here, guys. Can you calculate -11? Can you calculate -11? This will be a question in the quiz. This will be a question in the quiz, but maybe negative another number, -15, whatever. Okay. Again, there are different ways, but let me tell you the easy way. The easy way is I'm gonna make 11. Then I'm going to calculate the 2's complement of 11. It's going to give me negative 11. Okay, so let's do 11 first. So here, this one should be 1, 1, 0, 1, and then 0, 0, 0, 0. Okay, so this is 11. Is that okay? 11, right? Because this is 2 to 0, 2 to 1, 2 to 3. So it is 8 plus 2 plus 1, which is 11. So this is number 11. Is that okay, guys? Positive 11. So if I calculate the 2's complement of this one, I'm going to calculate the 2's complement of this one. First, I'm going to calculate the 1's complement. Then I'm going to add 1. So now it is 1, 0, 1, 0, 1, 1, 1, 1. This number, this one. Okay. So this number and this number are the same. But this is positive, this is negative. And because this is 1 is 11, so this one should be minus 11. Yes. Okay, what I mean, this is the weight of this bit. Okay, I'm going to give you one example. Look here. In our decimal numbers, okay, when I say, for example, I have $372, right? Let me ask you a question. So this 7 is more than this 3? For sure, no, because this one is in ones. So this one has a very little weight, right? This one is hundreds. So everyone here is very valuable, right? Because everyone here is in 100. Everyone here is in tens. You understand what I'm saying? Because everyone has a weight. It's the same thing in binary. In binary is, look here, if I have something like 1, 0, 1, 1, 1, 1, 1, 1, okay? So what is the weight of this one? The weight of this one is 1. What is the weight of this one is 2, which is 2 to 1. This is 2 to 0. What is the weight of this one? 2 to 2, 2 to 3, 2 to 4, 2 to 5, 2 to 6, 2 to 7. The weight, you got what I'm saying? So when I calculate the number, all what you have to do is, I'm gonna multiply every digit by its weight and then add everything together, okay? Let me explain it in a different way. You know, in the second grade or third grade, we used to tell the students, okay, if you have 372, this is in the ones, this is in the hundreds, this is in the, this is in the tens, this is in hundreds. How can you construct the number? How can you do that? In order to reconstruct the number or form the number, I'm gonna multiply 3 times 100. Because every one here, the weight of each one is 100 plus 7 times 10 plus 2 times 1. If you add everything together, you are going to get 372. You understand now? So here what I mean, 2 to 0, 2 to 1, this is the weight for every digit. In order to convert the number, I have to multiply the digit 1 or 0 by the weight and then add everything together. Similar to what we did here. This is the weight here is hundreds. The weight here is 10, the weight here is ones. That okay? So let me summarize what I said, guys, quickly. Okay, what I said here quickly, guys. Number 1, if I give you a binary number and I tell you this number is unsigned, okay? How can you, unsigned means it can be 0 or positive, okay? So how can you convert it to decimal? So all what you have to do, you have to multiply every digit by its weight. So here, this one, the weight is 2 to 0, 2 to 1, 2 to 2, 2 to 3, 2 to 4, 2 to 5, and so on, okay? By the way, in our numbers, we have the same weights, but instead of 2, we're using 10, okay? So for example, it's the same thing, by the way. So for example, if I have 372, what is the weight of this one? 10 to the power 0, which is 1. What is the weight of this one? 10 to the power 1. What is the weight of this one? 10 to the power 2. Makes sense, right? So we use the same thing, but because this one decimal, so the 10, so the base is 10, but in the binary number, the base is 2, 2 to 0, 2 to 1, and so weight, the weight for every digit, right? Hexadecimal, by the way, hexadecimal has the weight of 16. For example, if I have this number in hexadecimal, for example, 3AF, if I want to convert it to decimal, How I can do it? I'm going to tell you. The weight of this one, 16 to the power 0, 16 to the power 1, 16 to the power 2. Look here, guys. What I did in binary is the same thing what I did here in hexadecimal. It's the same thing I did in this one. The only difference is in binary, the base is 2, 2 to 0, 2 to 1, 2 to 2. In hexadecimal, the base is 16, right? In decimal, the base is 10. Weights, different weights, right? And then if I want to convert this number to decimal, so it should be 16 to the power 0, which is 1 for sure, multiplied by f, which is 15, plus a, which is 10, multiplied by its weight, 16, plus 3 multiplied by its weight, 16 squared. If I add everything together, so I'm going to get the decimal value of this number. Anyway, so this is how can you do it. Number 2, if the number is signed, if I tell you this number is signed, now there are 2 cases, guys. One case, if the number is positive, and you can know if the number is positive or negative from the most significant bit, right? So if the most significant bit is 0, that means the number is positive, right? And the way I'm going to do the conversion is similar to this one. I have to multiply every digit by its weight, right? This way. Also, however, if the number is negative, the most significant bit is 1. If the number is negative, okay, you cannot do this one. You cannot say 2 to 0, 2 to 1. You cannot, right? So there are different ways to do it. There are, maybe you have other way. I'm totally fine if you have another way. But the way I like to do it is, if I have a negative number, okay, I'm going to calculate the 2's complement. When I calculate the 2's complement, I'm going to get the same number, but in positive. So if this number is 10, I'm going to get is negative 10, I'm going to get positive 10, right? And now because the number is positive, I can now 2 to 0, 2 to 1, 2 and so on. Any question, guys? There are several things confuse students, okay? So let me say one thing confuses students here, and I want you to understand it. Look here, guys. Someone can ask me, why you put zeros on the left? For example, if you have a number like this one, 1, 1, 1, 0, 0, 0, 0, 0, okay? Look here. Someone can ask me, why all these zeros? Why it's not just 1, 1, 1, like this way? Okay, look here. In case you took a course before, digital system course. In digital system course, you have a number, right? So it's totally fine if you put it this way, 1, 1, 1 this way. Okay, it should be okay because it's as a number, this one and this one should be the same as a number. However, here in our course, because every number, as I'm going to explain later, every number is stored in a byte, physically stored in a byte. So even if you have 1, 1, 1, if you store 1, 1, 1 in a byte, so there should be zeros there. You understand what I'm saying? That's why any number I write, either it is in a byte or it can be in a word, because this is a container we have. As I'm going to explain in this course, in the memory we have locations. Every location should store a byte. Okay, so that's why I have to put zeros there, because there should be something stored here, right? You understand what I'm saying? So it has to be 8 bits. Even if you have 1, so I'm going to put zeros here to have to make it 8 bits because it's stored in a byte. Okay. If you want to store it in a word, I would put 0, 0, 0, 0, 0, 0, 0, because a word is 16 bits. Okay, so the reason I put zeros on the left, because I'm not writing like a number. I'm writing how it's going to be stored by the hardware. And in the hardware, I can store a byte or I store a word. You know what I'm saying? So that's why I have to put something here, zeros. Anyway, so one more thing. I already made this. So now, from now on, I assume you understand when I say the least significant bit, you understand what I mean by the least significant bit. When I say the most significant bit, you should understand what I mean by the most significant bit. Also, let's agree on this definition. When I say a byte means 8 bits. It's 1 unit of data, 1 unit, 8 bits. Even if your number is just 1 bit, if it is 1, 0, 0, 0, this is a unit. It's a unit, right? So even if your number 1, 1, 1, and then 0, 0, it's a unit. It has to be 8 bits. Even if your number, it just needs 2 bits. No, it's a unit, right? So that's why it's called a byte. Also, we have a word. A word is 2 bytes, so it's 16 bits, 2 bytes. You understand what I'm saying? So this byte, 8 bits, and then another byte 8 bits. By the way, also let's agree on this. This byte, I'm gonna call it the least significant byte. This one is the most significant byte. So if you have a word is 2 bytes. The first one on the right here, this is the least significant. The other one most significant. And you should understand, for sure, this is the least significant because this one has much lower weight than this one. So from now on, if I tell you the least significant byte, the most significant byte, you should understand what I mean. Okay? Your data, as I'm going to explain in this course, we have 2 types of data. Okay? Because this is a very simple computer. We have 2 types of data. Your data can be a byte or it can be a word, right? Based on what? Based on how much space do you need? Are you gonna, because a word, I can store more data in a word, right? So this is something you can decide in your program. Now I want to measure the temperature, or I want to measure something, but I don't need big space. No, byte is okay. No, but I want to measure something. I need big space. No, okay. So you have to move to word, or maybe you move to double word, and so on. Okay. So based on how big the number you are gonna store, right? So you can decide. I'm gonna use a byte or word and so on. Okay. Okay. I think that's enough for today, guys. I'm gonna continue next time.